All right, so finally, now we're going to make our initial conclusion about the null hypothesis. So in the case of this left tail test, we found the p-value to be 0.03. The question says use a significance level of 0.05 to test the claim. So since the level of alpha is given as 0.05 and our p-value is 0.03, I see that the p-value of 0.03 is actually a smaller number than the significance level alpha they gave me of 0.05. Whenever the p-value is less than alpha, that leads to the conclusion that you would reject the null hypothesis, because that's a miracle and something that only has a 3% chance happening is unlikely. Therefore, the null hypothesis is probably not true. This null distribution is probably not the correct distribution, and 52% is probably not the population proportion. So we're rejecting the null hypothesis that says that this is the correct population proportion. Reject the null hypothesis. All right. It also asks, does the conclusion change if the significance level is 0.01? Well, if the significance level is 0.01, then the p-value that we have of 0.03 will not be less than that. It will be greater than that. So we can reject this null hypothesis at a 5% significant level, but we cannot reject this null hypothesis at a 1% significance level. So changing that significance level would actually change the outcome of this test. All right, this is the second one. So we're trying to test the claim that 5% of Americans are vegetarian, and we are doing this at a significance level of 0.05 once again. So looking at this, my p-value here is 0.0003. So that would lead once again, since the p-value is less than alpha, that leads to the conclusion that I reject the null hypothesis. Reject the null hypothesis. Once again, what that means is, since I'm operating under the assumption that the null hypothesis is true, right? If the null hypothesis is actually true, the sample that I have actually observed, the sample actually only has a 3 in 10,000 chance of happening. So this would only happen 3 out of every 10,000 chances it had of happening, which is an extremely rare event, which is why I'm rejecting the null hypothesis. I don't think the actual proportion of vegetarians in the US is 5%, because if it is, I just collected a miraculous sample. All right, so I reject the null hypothesis there, and this null distribution is probably false. This is probably not the population proportion. All right. Oh, by the way, at a level of 1%, we would still reject this null hypothesis because this is extremely significant. So even at a 1% level, this p-value would allow us to reject this null hypothesis. All right, this next one, this was testing the claim that the proportion is different. And I got a z-score of -0.6 and a p-value of 0.55. So since I'm using a significance level of 5%, and in this case, my p-value is actually greater than my significance level alpha, which is 0.05 is alpha, but the p-value is actually 0.55, which is much larger. If the p-value is bigger than alpha, we fail to reject the null hypothesis. We can't reject it. So the conclusion here is fail to reject the null hypothesis. All right, so once again, to recap, if the p-value is less than or equal to alpha, reject the null hypothesis. If the p-value is greater than alpha, fail to reject the null hypothesis.